Welcome to this WiseOwl tutorial on creating calculated fields, sometimes called measures, in PowerPivot. Here's what you'll learn in this tutorial. We'll begin with looking at creating the underlying data model for this example, and then look at query context, tuples, and calculated fields and measures, probably the single most important part of the single most important tutorial in this series. We'll then look at comparing calculated fields against calculated columns and look at the differences between the two. We'll then look at how PowerPivot automatically creates implicit calculated fields for you whenever you drag a field onto a pivot table, how you can use Autosum calculated fields to create expressions quickly, and then finally how you can create your own calculated fields using the formula editor. We'll then look at that formula editor in much more detail before going on to look at some other functions such as sumx, averagex, etc., which is how you can perform statistics based on expressions, and the countrows function, which allows you to create ratios. And finally, we'll have a look at alternatives to the formula editor in PowerPivot, such as DAX Studio. So let's get started. In order to be able to follow through with this tutorial, which is probably, as I mentioned, the most important one in the series, you'll need to create the underlying data model. To do that, in a new workbook, go into PowerPivot, and if you choose to get information from a database. If you haven't already downloaded the database, you'll be able to get to the files needed from the link shown on the YouTube page. And previous parts of this tutorial explain how to create data models. I'm going to go through it fairly briefly. So I'm going to link to my SQL Server database and to the MAM database, and then if you could choose please 11 tables, which are the animal, center type, pos, product, quadrant, region, species, store, town, and transactions tables. And for each of these 11 tables rather, if you could please get rid of the TBL in the front of it. It's a bit of a tedious job, but when you're going to be creating DAX expressions, as we will be doing shortly, it makes sense to have tables which have easy to remember names and easy to find names. If everything begins with TBL, they'll be harder to find. So I'm just getting to my last one now, and then I can choose Finish, and I can then close down this dialog box. And if I go into Diagram View, you'll see the 11 tables in the underlying database linked together, and I can zoom in to see them all in one go. Now I'm only interested in the ones at the extreme edge of this diagram, so can I ask you to click on the title bar of the animal table and use the Control key to add on to that the product, pos, store, center, town, and region tables. And then if you right click on any one of them and choose Hide from Client Tools, they'll all be grayed out. In addition to that, if you could hide the ID fields from each of the three outlying tables, you'll just be left with the quadrant name, the center type name, and the species name. And from the transaction table, if you could get rid of everything but the price and the quantity. What I can then do is create a pivot table, and the fields available to me will be the ones I've left displayed in Client View. And if you could create this pivot table, we'll have the species across the top, the quadrant down the left, the quantity as the thing we're summing, and we'll display the center type name as a filter. If you could then choose the shopping center as a center type name, and what we're going to do is look in more detail at this figure 79. Before we can create calculated fields, I want to explain something called query context, the most important concept underlying the DAX expression language, which is what you use to write calculated fields. If you look at this number 79, it's the total sales for the East Quadrant, for the amphibian species, and for the shopping center type. I've taken the liberty of creating a separate worksheet containing all of the transactions. There's 13,900 odd of them. Now, what I'm going to do with this is to apply filters so that I can see just the information for the query context I've chosen. So I'm going to choose East as my quadrant, I'm going to choose amphibian as my species, and I'm going to choose shopping center as my center type. When I do that, it will show 79 as the total sales. So that corresponds to the 79 I'm viewing in the query context for that pivot table. Another way of looking at this is to use the concept of a tuple, which doesn't exist in PowerPivot but comes from analysis services and I find useful. What I'm going to do firstly is to look at what we've just done, and to do that, if I just press my magic function key, the tuple for this is the center type is shopping center, the quadrant is east, and the species is amphibian. So the tuple combines those three choices and shows the dimension choices I've elected to display in the pivot table, and the result is 79. What I'm now going to do is to change my view and look at this number 982. In terms of the data, what I've done is I've relaxed the constraint on the quadrant. So I'm now looking at all quadrants and not just the east one. And there's my figure 982. In terms of the tuple, what I've done is to relax the constraint, so I'm now looking at all the quadrants. So the value for the dimension for the quadrant in the tuple is all. I can continue this process now to look at this figure 13043. In this case, I've relaxed the species constraint. So doing the same thing from my data, I've taken the species and said I'm going to look at all species and not just amphibians. And in the tuple, what I've done is said I'm going to look at all species. So my tuple has now got all for the value for that dimension. And finally, I could relax the shopping center type constraint. So I'll say I'll even look at all of those. And there's the magic figure 19016. For the data, what I can do is remove the constraint for that. So I'm looking at everything, and you can see there's a figure 19016. And the way you'd express the tuple is by saying the value of the dimension is all in each case. Finally, before I leave this section, I just want to talk about names for things. In PowerPivot for Excel 2013, I'm going to talk about calculated fields, not calculated columns. And in the next part of this tutorial, I'll explain clearly the difference between these two things. One of the problems with PowerPivot in previous versions of it, and also in analysis services, they weren't called calculated fields, they were called measures instead, which in my humble opinion was a much better name. And so you'll probably hear me at some stage during this tutorial accidentally referring to a calculated field as a measure instead. But I won't be alone in that. Some Microsoft error messages and dialog boxes still use the word measure, and I wish they would revert to that term. So I will use the words calculated field and measure interchangeably, although I'll try to use calculated field where I remember. What I want to do now is briefly explain the difference between a calculated field and a calculated column. I've created a calculated column within the transaction table, and what it does is determines for each transaction whether it was a single purchase because I only bought one item or a multiple purchase. And this can be used as an aggregator column to analyze data into the two categories single and multiple purchases. A calculated column never involves aggregation. So for each of these separate rows, all the 13,904 rows, it will calculate the value for this field separately. There's no aggregation involved. By contrast, a calculated field always involves aggregation. So if you look at any of these pivot table cells, there will always be the concept behind it of a set of data forming the query context, and whether it's summing or averaging or taking the highest or lowest value or any other statistic, it's always the case that there is potentially more than one row feeding into that number. I've already mentioned that the quantity column, which is being summed in the values section of the pivot table, is a calculated field. But you may be sitting there thinking to yourself, I don't remember creating that. But you did, because whenever you drag a numeric field down into the values section of the pivot table, PowerPivot automatically creates an implicit calculated field. Now if we go into PowerPivot, initially it looks like those aren't being displayed. I'm on the transactions table, and you would expect them to appear in this grid at the bottom, which shows the calculated fields you've created. The reason I can't see them is because I've chosen not to show them. By default, PowerPivot doesn't display them. But if I click on Show Implicit Calculated Fields, then they'll appear at the bottom in the grid. Not necessarily in the right place. This one happens to be at the bottom of the column to which it applies. And when I click on that, you can see it has a name, sum of quantity, and in expressions giving the sum of the transaction quantity. As well as creating implicit calculated fields, you can use the Autosum feature to create your own. To illustrate how this works, I'm going to add the average price into my pivot table. To do this, I can go to PowerPivot and I can click anywhere at all within the price column. On the Home tab of the ribbon, in small font on the right hand side, is a statistic you can choose. So I can click on the little drop arrow and choose whether I want to average or count or sum the price. I'm going to average it. And what it will do is automatically create an additional calculated field. You can see the expression for it is to take the average of the price. If I now go back into Excel, the extra calculated field I've created will automatically appear within the transaction table. There it is. And I can tick on that to include that in my pivot table and possibly remove the sum. Perhaps it's a good idea to format that so it looks a bit more presentable, but it's not strictly speaking necessary. So I'll do it to 2 decimal places, and there's the average price for each query context. I think it's worth mentioning at this point something which doesn't do what I've just done. If you go back to PowerPivot, there's a very similar looking option on the Advanced tab called Summarize By, and it's worth explaining what this actually does. Supposing whenever I drag the quantity column onto the pivot table, instead of summing it as would happen by default, I want instead to take the average. What I can do is choose average as the default way in which I'll summarize this statistic in the client tools. If I now go back to Excel and if I tick my quantity column, what it will do is add the average quantity into the pivot table rather than the sum, which would have happened by default. When I go back into PowerPivot, you can see that it's created an additional statistic for the average quantity. Now, I didn't want to do that, so I'm just going to get rid of that extra calculated field, and I'm also going to change the quantity back so it summarizes in the default manner. But I thought I'd explain what that very similar looking option does. We've managed to get to this point without creating our own explicit calculated field using this option on the ribbon, but that can't go on any longer. I'll just remove the existing average price I was displaying in the previous bit of this tutorial, and what I'm going to do is create my own explicit measure, or explicit calculated field I should say, to give the total quantity for transactions for the query context in the pivot table. It's going to be an exact duplicate of the one which was already created as an implicit calculated field, but we have to start somewhere. To create a new calculated field, you go to Calculate a Field in the PowerPivot tab of the ribbon and choose to create a new one. I can choose a table name. For many years, or many months anyway, this confused me more than anything else in PowerPivot. I finally discovered that it makes no odds which table you put your calculated field in. It will work just as well in any of them. Indeed, some people on the internet recommend creating a separate dummy table just as a container for the calculated fields that you create. I'm going to put this in the transaction table because it's doing total quantity and that's in the transaction table, but it would work equally well whichever table I put it in. I'm going to call my new calculated field total QTY. I'm putting the space in just to prove that you can. I could optionally type in a description for what this is doing, and then I can go to the formula bit of the dialog box and type in any valid formula. And the next 2 or 3 sections of this tutorial series, we're going to be looking at all the possibilities you can put in here. For the moment, we're going to do the most basic thing possible and sum something. So if I type equals sum open brackets, the formula or the expression I'm going to sum is a quantity. If I type a single square bracket, it will come up with all the fields available to me in the transaction table. So I'm going to choose the quantity field, and then I can close the brackets. I now want to check if that's a valid formula, so I can click on Check Formula, and it passes my test. It's a bit irritating that the message saying there's no error always is obscured by this pop-up caption. But if I click there, I can see it says no errors in formula. It's always a good idea when creating a calculated field, it makes life easier, if you format it at the time you create it, so the format travels with the calculated field. I'm going to display this as a number. It's actually going to be a whole number, you can't buy half a bear, and I'm going to put in 1,000 separator in. When I choose OK, what PowerPivot will do is not only create my new calculated field, there it is appearing in the transaction table, but elects also to display it in my pivot table. If I display the implicit calculated field alongside that, for every single possible query context in the pivot table, the 2 values should be exactly the same. It would be very scary if they gave different answers because they're doing exactly the same thing. One of the main differences between an implicit and an explicit calculated field is you can use the latter as a basis for a KPI, or key performance indicator, but more on that later on in this tutorial series. At the risk of being repetitive, we're now going to create a calculated field giving the total quantity again. The reason I want to do that is I want to show a bit more about how the expression editor works, but before we do that, let's clear up some of the clutter we've left behind. It'd be nice to be able to right-click on a calculated field and choose to delete it, but that was taken out in this version of Excel for technical reasons. So instead, I've got to go to this drop-down, choose to manage my calculated fields, and then individually delete each one in turn, confirming my choice by choosing yes. That will get rid of all the explicit calculated fields, but it won't get rid of the implicit one I created. Even if I untick it, it will still exist in the underlying PowerPivot data model. So what I'm going to do is go back into PowerPivot and right-click on it to delete it here. If you can't see your implicit calculated field here, don't forget that you can go to the Advanced tab and click on this button to display it. So once I right-click and choose to delete that, I should be left with no fields in my underlying transactions table. I've just got the price and quantity. I'm now going to create another calculated field, and this time I'm going to put it again in the transaction table and call it QTY, but this time we're going to have a bit of a longer look at how to actually use the expression editor. One of many things you can't do with this is to increase the font size. In fact, this isn't my favourite bit of PowerPivot, I'll be honest. What I'm going to do as before is to sum something, but this time I'm now going to press Shift and Enter twice to put in a couple of carriage returns. By doing this, it can make a complicated expression easier to read, but it does have a downside, and the downside is that PowerPivot can quickly lose track of where you are in IntelliSense, and it can be quite hard to get this back again, although on this occasion it's actually worked. At this point there's two punctuation characters I can type in. I can type in a single square bracket as before, in which case it will come up with the fields stored in the table in which I'm storing the calculated field, or I can get rid of that and instead type in a single apostrophe, in which case it will allow me to choose which table I want to refer to. I'm going to go for the transaction table, and I'm going to choose the quantity field within it. So what I've done is explicitly reference not just the field, but also the table containing it. But it will give me exactly the same result as the previous formula did. As before, I can check this, it accepts it, and I can choose my number format as before, so that it will automatically display correctly in a pivot table, and when I choose OK, I'll get this expression appearing again. The pivot table as visible here, which should look quite familiar now, is summing the quantity of transactions sold. But what would happen if I wanted to sum the amount, which is the price times the quantity? One way I could do this, and to be honest probably the easiest way, is to go into PowerPivot and create a calculated column. So I could, for example, put in equals price times quantity. I could call the new calculated column that I've just created something like amount. And then back in my Excel workbook, I could just sum the amount. However, if I did it that way, you wouldn't learn about the SUMX and other related functions. So I'm going to delete that column and do it the hard way. To create a formula which sums the amount, we can create a new calculated field as usual. I'm going to put this in the transaction table so I can have easy access to the fields in it, and I'm going to call it total amount. I can then type in my formula, equals sum. If there's one thing I've learned from PowerPivot, it's to believe the IntelliSense given to me. It says it's looking for a column name, and I'm actually going to provide it with an expression, price times quantity. Now what this means is if I try doing price times quantity, typing in the single square brackets to get access to the fields, it's doomed to failure. And you can see that because if I click on check formula, it tells me that the sum function only accepts the column reference as an argument. I should really have believed it. The solution to this is to use a different function called SUMX. I put that in uppercase, but in fact functions aren't case sensitive in PowerPivot. You can see this expects a table and an expression. That's looking more like what I want to use. The table in this case is going to be the transaction table from which I'm drawing my expression, and the expression itself will be the price times the quantity. I can then close the brackets for that. And this time when I click on check formula, it should work. This is actually going to be a currency. I'll leave it as pounds. So when I choose OK, what it should do, at least when I tick on it to display it in my formula, is display the total amount. There's a few functions like this. Here's a list of them. Basically, you take a normal function name and stick an X on the end. I think my favourite is probably the Minx function. I doubt many people watching remember Minnie the Minx, but I have fond memories of her in the comics I used to read as a child. What I want to do now is to work out the ratio of the number of transactions for any shopping centre to its square metre area. Presumably the higher the ratio, the more successful the shopping centre. In terms of fractions, you can express them as the numerator over the denominator or just a over b. In my case, my numerator is going to be the total quantity of transactions for the shopping centre, and the denominator, the bit at the bottom, is going to be the total square metres area. And in doing this, we'll learn about the count rows function and also learn a bit about calculating ratios correctly in PowerPivot. So the first thing I'll do is get rid of the current quantity being displayed. And what I now want to do is pick up fields from the center table. To do that, I'm going to have to go back into PowerPivot, and I'm going to have to stop that being hidden from client tools. I probably don't want anything but the first few fields, so I'm going to hide all those. And I'm going to delete this one which I actually created earlier when I was practicing. What I can then do is go back into Excel and I can create my first calculated field. What I'm going to do is put it in the center table because that's the level of granularity at which I want to calculate this. I'm going to call it number of transactions because that's exactly what it's going to be, and hopefully I'll spell it correctly. And I'm going to use a count rows function. The count rows function assumes you'll pass in a table name, and we're going to count how many rows there are for each shopping centre in the transaction table, so basically how many transactions there are, and I'll store that as a whole number. If I choose OK, you can see it's showing how many there are for each shopping centre. The reason this create button appears is PowerPivot is a bit unhappy that I'm not actually showing the shopping centre and that I'm diving into a level of granularity which is inappropriate to the calculated field I created. But it is actually giving me the correct answer, and even if I click on the create button, all it asks me to do is create a random relationship with no guideline where to go. You can see that if I go back into my data diagram view, all my relationships are good and sound, so it's still going to work. The next thing I need to do is to create the ratio itself, so I'll put this again in the center table and I'll call it, without any great imagination, ratio. What this is going to do is take the number of transactions. Well, I've already calculated that, so there's no need to repeat the formula. I can pick up on it by typing a single square bracket and choosing number of transactions. I'm going to divide that by the square meter area. The temptation at this point is just to put in square meters. If I do that, when I check my formula, it will give me an error. What it's trying to say is that I'm not doing any aggregation. Don't forget there's always a concept of query concept going on behind the scenes. So I've either got to sum the square meters or average them or perform some sort of statistic on them in order to be able to produce a meaningful calculation. In this case, what I'm doing is summing them. That's going to make more sense as a ratio. It's going to create a very small number. There aren't many transactions and there's some fairly big shopping centres, so I'm going to multiply that by a fairly arbitrary figure of 10,000 to make it look more readable. I'll store it as a decimal number with 2 decimal places, and then I should be able to choose OK. It's now showing the ratio. What's important to realise about this, in fact what's absolutely vital to realise, is that the ratio is being calculated correctly at every possible level. So for example, for this cell 0.66, it's calculating the ratio for shopping centre, east and amphibian. It's working out the total quantity of sales for that particular query context, working out the number of transactions for that particular query context, and dividing one by the other. It's doing exactly the same thing at every level. So even at this total ratio for all shopping centres, it's still calculating the total sales separately and dividing that by the total number of transactions, or rather the other way around. What it doesn't do, for example, is take the average of the total ratios, which is what it might be tempted to think you'd do. I've already mentioned that I'm not a big fan of the expression editor within PowerPivot, For one thing, the font is way too small for my tired eyes to read, and for another, IntelliSense tends to give up new from time to time. So I looked around for an alternative, and there is one called DAX Studio. I'll show you now how to download it and install it, but I don't necessarily recommend it. It's quite buggy for one thing, I found. If you go to Google, other search engines exist, and choose to type something like WiseOwl DAX Studio and run your search, you'll be able to get to our blogs on DAX, and one of them is on DAX Studio itself. This gives full instructions on how to install DAX, but I'll take you through the process now as well. What you need to do firstly is to go to the relevant site and click on the download button to download the application. It's not very exciting watching that, so here's one I prepared earlier. You can then double click on the setup instructions, agree all sorts of scary dialog boxes, and eventually it will take you through and actually install the software. I'm going to install the full Excel add-in. I don't want to create a desktop icon, and having installed it, I don't really want to run it as a standalone application. I'm only interested in running it from within Excel. The next thing you need to do is to make some changes to your registry, always a scary thing to do. It may well be the case that this is only relevant if you're running Windows 7 and a 64-bit machine as I am here. The web blog tells you how to create this registry file. I just pasted in the information. Having done that, you can then run it, and what it will do is make the relevant change to your registry. Having done all of those changes, what I should now be able to do is to go into Excel and use DAX. If I go to the Add-ins tab, it should appear there. If it doesn't appear, what you'll need to do is go to File, choose Options, go to Add-ins, choose COM Add-ins, click on the Go button, and tick the Excel add-in box. And for some reason there are often two appear. So what I'll do is try changing to the Excel add-in. What I can then do is create my expressions within DAX Studio. If I click on that, it will ask me which PowerPivot data model I want to connect to. And what I'm going to do is use the one within the Excel workbook. I can click on Connect, and what that allows me to do is to drag expressions in. I can even type in comments, which deserves an exclamation mark, and I can drag fields or tables in from the left hand side. So if I wanted to do the same expression as I've done a few times already, I can say sum of the quantity, close the brackets, and then I could copy that information and paste it into my expression window. Whether all this is worth it, I'm not so sure, but if you're running standalone DAX queries in Excel or anywhere else, you'll definitely enjoy using DAX Studio. For the moment though, I'm going to close that down without saving any changes, and I'm actually going to disable the add-in because I don't want it to appear later on in this tutorial. So if I go to COM Add-ins, click on Go, and I'm going to delete or remove both the two add-ins, which I can only do when I'm an administrator, so it appears that will have to wait. And that completes this tutorial on basic expressions, or basic calculated fields. What I'm now going to do is show some of the more advanced things you can do with the DAX expression language. If you like what you've seen and heard so far, why not head over to the WiseOwl website, where you can find loads more free resources, including these videos, some written blogs and tutorials, and even some exercises that you can download to practice your skills. Thanks for watching, and see you next time.